What's good, math family? In this video, we're going to look at quadratic and absolute value graphs and how to determine when it's increasing versus decreasing. As we start this video out, we have to understand the difference between a positive slope and a negative slope, because this is going to help us identify when the graph is increasing versus decreasing. Number two, we have to understand that the axis of symmetry is going to be important for the intervals of increasing and decreasing. All right. So now that we got that, what is the domain? So domain is all real numbers. And sometimes you see it expressed as interval notation as negative infinity to positive infinity. Now, when we get to the range, understand we're asking what y values are included in the graph. So when we look here, the lowest y value is 2, so this is where it starts. So for my range, I know we start at 2 and it's included, and it's going where? To all the numbers greater than 2, so we use infinity to basically represent all those numbers. Now what happens is they may express it as interval notation or an inequality where they come in and say y is greater than or equal to 2. Any of these two answers will work. Now, another thing we need to know is the maximums and minimums of the graph. A maximum is just a high point, but if the graph is trending up, there is no high point. So we do not have a maximum, but we do have a minimum, a low point of the graph, which would be my vertex. So my minimum for this graph would be at -3, 2. Now we get over to the bulk of this video, which is intervals of increasing versus decreasing. So imagine that we are following the graph, right? We're following the graph line. So we know all these values, right? As this parabola gets wider, we're coming from all those negative x values. So as we're coming down from negative infinity to our vertex, what is happening to my y values? They are getting smaller, aka decreasing. And they're going to decrease all the way until the vertex. And when we do intervals of increase and decreasing, we always focus on the x. So I know that this is decreasing from negative infinity to my x value, which is -3. Now, when we go over to the other side of the parabola, right? So now we're at 3, we're going to positive infinity. When we follow this line, we notice that what? My y values are getting bigger. So we know it's increasing from the interval when x is -3 to positive infinity. Now, let's say we had a different graph, right? So this graph opens down. How would this change? So we have something like this. And my vertex now is at, let's just call this, let's call this 4. No, not 4, I'm sorry. Let's call this 2, -1, right? How would this change? So for one, domain is still the same. All real numbers. However, when we get to the range, graph starts from the bottom. So we're coming from negative infinity, and it stops where? When y is -1. So for my range, we're coming from negative infinity all the way up to -1, and we have a bracket because that answer is included. Now, if it's an inequality, all we're going to say is y is less than or equal to -1. So we got that done so far. We're now on maximums and minimums. So if the graph opens down, there is not going to be a minimum. So there is no minimum, right? But there is a maximum. And our maximum, one of the highest point on the graph is right here at +2, -1. So this is how we identify the maximum for a graph that opens down. Now we get over to intervals of increasing and decreasing. I know my axis of symmetry, x is equal to 2. So that's what's going to be the number that's in my interval notation. So again, we're following this graph, coming from negative infinity up to our vertex. What is happening to my y values? They are increasing. So I know this is increasing from what? Negative infinity all the way up to 2. Then when we hit that vertex, and we're now talking about positive 2 now, right? We're talking about 2 to infinity. What is happening to my y values now? I'm noticing that as I go to positive infinity on the x-axis, my y values are now getting smaller. So I know that this is going to decrease from 2 to positive infinity. With absolute value graphs, very similar to quadratics. So when we look at this and we're trying to find a domain, we know the domain is going to be all real numbers, right? So all real numbers. Now, when we get to the range, we start from bottom to top. So this starts at 0, and we know it's going to keep on going. So we're just going to use positive infinity for that. So my range is bracket 0 to infinity. Infinity always has parentheses. You may see it as an inequality, which will be y is greater than or equal to 0. Now, because this graph opens up, there is no relative maximum, all right? So we're just going to leave that blank. Now, we do have a relative or just a minimum, which occurs at 0, 0. So that is the minimum for this graph, no point lower than that. Now we get over to intervals of increasing and decreasing, right? So when we look at the axis of symmetry, right, we're focusing on the x-coordinate. So when we're coming from negative infinity, we're following this graph all the way down to our vertex. What is happening to our y values? They are getting smaller, aka decreasing. So I know this is decreasing on the interval negative infinity all the way to 0. Then when we stop at 0, and then now we're going on the other side to positive infinity, right? Going to the positive infinity. What is happening to our y values? They start to increase. So we know that we are going to be increasing from the interval 0 to positive infinity. Now, let's say we had a different graph. And in this graph, for some reason, it opened up. Not up, I'm sorry, down. So let's say this is the graph we have, right? They gave us the point 5, -3. How would this information change? So let's see. Domain, anytime it opens up and down, 9 times out of 10 is going to be all real numbers. So we could put negative infinity to positive infinity. Same thing as all real numbers. Now we go to the range, right? So remember, this graph opens down. So we're coming from what? Negative infinity. And this graph goes all the way up to -3. And because it's included, we have a bracket. Now, if I express it as an inequality, y is what? Less than or equal to -3. So now we're done with that. We're on to our maximum and minimum. And like I said, now we don't have a minimum because this opens down instead of up. So my maximum would occur at 5, -3. Our vertex is now the maximum. And when we get over to the intervals of increasing and decreasing, let's think about it, right? So we're coming from negative infinity, we're going up to our vertex. What is happening to these y's? They are increasing. So we know we're increasing when we're coming from negative infinity all the way up to +5, right? That's the first half of the graph because we know that vertex cuts it in half, right? Axis of symmetry. Now we're on the other side. So we're talking about 5 to positive infinity, right? So as the x's are getting larger, 6, 7, 8, 9, 10, what happens to the y values? They are decreasing. So our decreasing interval is going to be from 5 to infinity. And all you have to do is just follow that line. Really hope this video on intervals of increasing and decreasing was helpful, family. Smash the like button, and if it was, comment to subscribe to our channel and comment down below if you have any questions on any of these problems that we did in today's video. Thank you guys so much for watching.